Hey everyone, this is Rohan Shah with BestEconTutor.com, and in this video we'll be talking about the budget line and utility, the rational spending rule, and income and substitution effects. So, let's talk about the budget constraint. Now, suppose you're in a situation where you have a $10 income and that you can buy good X or good Y, apples or oranges, for example. Let's say that the price of good X is $1 and that the price of good Y is $2. Now, let's try to think about all the possible bundles that you're able to consume. Now, here, if X costs $1 each, well then you can buy with your $10. If you wanted to, you could buy all 10 of good X, right? So then you'd have 10, you could spend all $10 on good X, and so you'd be able to buy 10 of them. But then you'd have 0 of good Y. So again, any point on this plane here is a bundle. It's similar to a PPF from the beginning of the course, but now it's for the consumers, from their point of view. How much, it's really about their budget constraint. What are all the bundles that they're able to consume? One big assumption here, again, is that your income's only being spent between these two goods, and so these are the only two goods in the world, so you don't want to waste your income. Now let's say good Y costs $2. So now, for out of your $10 budget, if you were to hypothetically spend all of it on good Y, for $2 each, you could buy 5 items of good Y, right? 5 each at 2 each would be your full $10 income. So that with 0 units of X is also another bundle. So now, and really you can buy any sort of combination here. For example, you could, buy, if you were to buy 40 units of good Y, then that would be $8. So you'd have $2 left to spend on good X, and so you could buy, 2 units of good X. So that's 4, 2 is a point here, and so on. But either way, if you were to make your budget constraint, you'd find that the slope is always equal to, here the slope of this, it's negative of course because it's downward sloping. To buy more of one good you have to give up some of the other because you're on a budget. But here the slope, the rise over run is 5/10. The slope is a half. So the slope, by the way, of the budget line, the slope is always going to be negative, but then it's always P of good X over P of good Y. So there's that. It's always, here in this case it's a half, and if you look at the price of good X over the price of good Y, 1/2, that is a half. It's not just a coincidence. We won't get into this math, but if you wanted to, you could write out the mx plus b using this budget constraint, px times x. What that is what each unit of good X costs times how many of them you buy. That's how much money you spend on good X. So if you were to buy, 3 bananas at $2 each, then 3 times 2, that's $6. That's how much you spent on bananas, plus the price of good Y times how many units of Y you buy. That's how much money you spent on good Y. That has to equal your income. So this equation is called your budget constraint. And if you rewrite it such that you have Y on the Y-axis and X on the X-axis, you end up actually getting that it's like an mx plus b, but the slope here is negative, px over py, is this slope here, plus, some intercept that you can get. But either way, the slope is always this for the budget line. So now what that means is, on this plane, if you were to ask yourself, hey, could you afford to buy this point over here with this x, y coordinate? Not really, it's outside your budget constraint. Could you afford to buy this point? You could afford to buy it, but it's probably not the single best point you want to buy because, you could buy more of each good, by going somewhere here on your budget constraint, or you could buy more of both and be happier. So really, your single best point is probably going to be something on your budget constraint. But here's a question, almost tricky question. Which point is better, this point or this point? Well, it's actually unclear. And this is where utility comes in. Yeah, sure. This has, not spending your entire income amount, so you're wasting money. That's not the single best point. and this does have you spending all of your income, but this point might actually give you more happiness than this point. Because what if the two goods here were, what if X was houses and Y was pens? Well then, sure, here you're spending all your income and you have a lot more pens and 2 houses, but this one, even though it has fewer pens, has more houses. So even though you're not spending all of your money, you might want more houses than pens, right? So who knows which one is, better. So that's where utility comes in. So this is almost a completely unrelated thought process on the same graph, on the same sort of X and Y axis of, how many units of good X and units of good Y. But here we're not taking the prices and your budget into account at all. We're just looking at your happiness level. So if I were to ask you, which point do you prefer, this point or this point, without even any numbers, you can say that this point over here, the second point, is better because it has more of both goods. So this is strictly preferred to this. But if I were to ask you, which do you like, this point or this point, it's unclear. This has more of good X, this has more of good Y. So it's unclear which one's better. They might even give you the exact same level of happiness. Suppose they do. Suppose this point and this point gives you the same level of happiness. Well, what that means is they're on the same indifference curve. So that's a new term, indifference curve. IC you can abbreviate it as. Usually looks something like this, and what it's giving you is the set of all bundles, they give you the exact same level of happiness. The useful thing about this is now you can actually compare any 2 points on the plane. For example, if I wanted to compare this point with this point, and I know this indifference curve, see, without this indifference curve, it's unclear which point is better. This has more X, this has more Y, and so it's unclear which one's better. But now we can say for sure that this point is better, means that it gives you a higher utility than this point. Because this point, one way to think about it is this point, it's up and to the right, meaning compared to this point, right? So if you wanted to compare these two, you can definitely say that this circled point is better than this guy. But this guy is the same as all these points, including this one, for example, which is definitely better than this because it has more of both goods compared to this bundle. So this is called the transitive property. You don't really need to know that, but any point on this indifference curve is definitely better than point A. But any point on the indifference curve is also definitely worse than point B, because point B is up and to the right of the indifference curve. So by transitive property, we can say then, well then, if B is better than all these, and all these are better than A, well then B is definitely better than A. So you can use indifference curves to kind of, solve for, or kind of to figure out which points are better than others, even, even if it's not clear. But now, here's a question. The slope of the indifference curve. What is the slope of this indifference curve? See, unlike this budget line, which had the same slope everywhere, this guy's slope changes everywhere, right? But either way, the slope of this is what we call MRS, marginal rate of substitution. So marginal rate of substitution, and it's equal to, it's negative. Notice that indifference curve always have to be negative. An indifference curve can't slope up, because if it did, if you had an indifference curve that sloped up, what that means, again, indifference curve, just anytime you're confused, just try to think about the meaning. What does an indifference curve mean? Indifferent means, they're both the same. You're indifferent. I don't care this one or this one. So this means you're indifferent between these 2 points. They give you the same happiness level. But that doesn't make sense, because this has more of both goods, X and Y, compared to this. So why would you be indifferent between them? You wouldn't. You'd prefer this. So that's why if something sloped upwards, it's not an indifference curve. So the indifference curves definitely have to have a negative slope. Specifically, the slope of an indifference curve is always negative mu, marginal utility of good X, over the marginal utility of good Y. Again, this is the same thing as MRS. And that's how you find the slope at every point. Now, marginal utility, marginal, next one, utility, happiness. Utility just means happiness. So this is saying, what's the extra happiness you get from one more of good X? That's what your mu is. And so now this sort of explains now why this thing is not just a perfect line usually, and why it gets less and less steep, right? Notice how steep it is over here compared to over here. The indifference curves always get less steep. So, and it's because as you have more of good X, as you have more pizza, each slice becomes less and less valuable. The marginal utility decreases as you have more of any good, and that's why the slope gets smaller, and so it becomes less steep. Now let's talk about what's called the rational spending rule. Here's the rationale. Now let's kind of merge these two worlds into one graph. What if we were to put in a budget constraint into this graph, for example? Here's the thing. Let's say there's really three possibilities of what an indifference curve could be like compared to the budget constraint. It could either totally not touch it at all, like it is over here, or an indifference curve could be tangent, meaning it only hits it at one point, or it could kind of intersect like it would over here. So here's the question. If we want to find the single best point that you can consume, let's see, there's three possibilities. Either that single best point could be, you know, somewhere where it's not hitting an indifference curve at all, but that doesn't make sense because all these points are unaffordable. So we can just rule that one out. So the only cases are either it's, you know, the indifference curve is intersecting the budget line like this, intersecting and going through, or it's tangent, meaning it touches it only at one point, you know, and it has the same slope over there rather than intersecting like this. So let's just, you know, what if somebody were to say, hey, you know what, if we were the first economists and we were wondering, hey, what if this point, you know, where if we were to redraw it here, where the indifference curve and budget line intersect, like over here, what if that's the single best point? Could that be the single best point? Well, let's see. Compared to this point, what are all the points? Here's a question. What are all the points that are better than this point, or really any point? Well, if you want to find all the points that are better, just, you know, shade everything to the right of the indifference curve. So, what are all the points better than this? Well, you know, the black shaded region over here. And here's the thing, of all those points that are better, meaning gives you a higher utility, by the way, each indifference curve corresponds to a specific happiness level. So that's why the more up and to the right the indifference curve is, the happier you are. So really all these points, all these shaded, the whole shaded region, all those bundles would give you more happiness than this guy. But here's the thing, out of all those points, this region specifically, that I've sort of really shaded over here, these are affordable. They're within your budget line. So if we were wondering, is this the single best point that you can consume? Not really, because there's a whole region of points that are better and affordable. So we now can sort of say that anytime you want to find the single best point, it's not going to be where an indifference curve intersects with the budget line. So the only remaining option is it's got to be where it's tangent. And just to further kind of see why, the only points better than this are all here. But, or, you know, if we were to make a graph again, it's like the only points better than this are here. But none of those points that are better are affordable. So, you know, this is kind of, you know, and if you think about it, the only other affordable points are on lower indifference curves, right? All these other points on the budget line are on a lower indifference curve than this guy where it's tangent. So now, again, you don't really need to, this is just sort of explaining why, but you don't need to recreate that reasoning every time. Just know then that this is why the best point is where the indifference curve and the tangent line are tangent to each other. Now tangent, if you were to ask a mathematician, what does tangent mean? Well, in part it means that the two things that are tangent have the same slope. So, well, guess what? If we want to find where their slopes are equal, we know what the slope of the budget line is. The slope of the budget line is negative px over py. And we want that to equal the slope of the indifference curve, which is negative mux over muy. There you go. And this, you can rewrite this if you wanted. You could just you know, cross multiply and divide and get rid of the negative sign because it's on both sides, and you'd get mu of good x over p of x equals mu of good y over p of y. These two are again saying the same thing. And either way, this is called the rational spending rule. That means if this equation is true, you're maximizing your utility. So basically, if you want to find a problem where you're maximizing utility, this is a condition you got to check for, that the extra happiness per dollar is equal for both goods. Now finally, let's talk about the income and substitution effects. So here's one to use them. Whenever a price changes in the world and you're wondering, am I going to buy more or less of different goods now? Well, that's when you want to use the income and substitution effect to figure that out. Here's the thing. The income and substitution effect, think of them as like the devil and the angel, right? Both of them are giving you, advice, sometimes conflicting, sometimes the same. But either way, your end result, what you end up doing, what you physically end up doing, your reaction to a price change, is sort of the sum of both of those, the income effect and the substitution effect. So let's take a look at an example problem. Let's say apples and oranges are both normal goods. So apple, normal, and oranges are normal. And let's say that the price of apples increases. We want to see now what happens to the quantity of apples versus the quantity of oranges. Now, all right, and so really what we're going to do is we're going to first find the substitution effect and income effect and see what each one is saying. So now let's generalize. What is the substitution effect? Well, that's probably the thing that you're more familiar with, that if any price in the world goes up, you want less of that good. It does go one step further, though. It says that if any price goes up, not only do you want less of that good that's more expensive, but you want more of other goods. You're sort of substituting with that same amount of money. You're substituting, so you're actually buying more of other goods. So in this case, if apples are more expensive now, the substitution effect is very much like the law of demand. If price of apples increase, you want less apples. Not only that, but even though oranges price haven't changed at all, you do want more oranges, right? Part of you is saying, hey, get less apples, but get more oranges now instead. So that's what part of you is thinking. Notice this doesn't mean that that's what you're physically going to do, because we also have to take the income effect into account. One thing to notice, though, about the substitution effect, it doesn't depend at all on whether these goods are normal or inferior, right? We don't use that at all. So again, just to recap, substitution effect is basically saying if any price goes up, normal or inferior, buy less of that good and more of the others. And the other way around, if a price goes down, buy more of the good whose price went down and less of the other good whose price didn't change. Now the income effect. What this one is saying is that when any price goes up, doesn't matter which good, any price goes up, it's as if you're poorer, right? Because you can afford less stuff. The price went up, you're poor. So if any price goes up, you're poorer, so you want to buy less of every normal good and more of every inferior good. So here, and the other way around, if a price goes down, it's as if you're richer. So you're going to buy more of every normal good and less of every inferior good, not taking into account at all which good's price changed. So you might even have a case where, a price of a good went up, but you still wanted more of it because, it was inferior or something like that. But either way, let's just systematically look at it in this problem. If price of apples increase, well, the best way to think about income effect is you want to immediately translate that into are you richer or poorer. So if a price increases, doesn't matter which good, you're poorer. So if you're poorer, you want to buy less normal goods, more inferior goods. So is apple normal or inferior? It's normal and you're poor, so you want less of that good. Oranges are also normal, so you also want less of that. Notice that in this case, if either of one were inferior, the only thing that would change is the arrow for income effect would then now be greater. If it's inferior, you're poor, you want more of it. So again, this could be if both of them were inferior, they'd both be upward arrows. If one of them was, then only that one would be upwards. Either way, the end result, what you end up doing, well, let's see. For oranges, this guy's saying, buy more oranges. This guy's saying, buy less oranges. So you're kind of conflicted. So the amount of oranges you end up buying is actually ambiguous. Part of you is thinking, hey, apples are more expensive, so let me buy more oranges. And another part of you is like, I'm poor, I should buy less oranges. But for apples, well, let's see. The devil and the angel are both agreeing with each other. They're both saying, hey, you're poorer, buy less apples. And this guy is saying, apples are more expensive, buy less apples. So you're like, fine, I'll buy fewer apples. So that's how you can use the income and substitution effect to figure out whether a price change causes you to buy more or less of a certain good and whether it's ambiguous. All right, now let's look at a question from a student. Can two indifference curves intersect each other? All right, well, there's a set of rules that indifference curves must obey. One of them is, in fact, that two indifference curves cannot intersect. Here's why. Here's a simple way to think about why. If this is an indifference curve, and this is another indifference curve, and let's say they intersect, here's the issue. What about this point? What about that intersection point? Technically, that's equal to all these points. Let's say that's indifference curve A and indifference curve B. This is equal to all, it gives you the same happiness level as all the points on indifference curve B and all the points on indifference curve A. So by transitivity, technically, if all these points on both of these indifference curve gives you the same happiness level as that point, well, they almost equal each other anyways, right? So if all these give you the same happiness level as each other, you know, well then that's a contradiction, right? Because if you look at it, indifference curves aside, this guy gives you more happiness than this guy, right? Because this is up and to the right. But, so on the one hand, we're thinking this is preferred to this. But on the other hand, they're both equal to this guy. So that doesn't make sense that they're equal to each other because they're equal to this, but also that this has more of both goods. So you run into all sorts of problems if you have indifference curves that intersect, and that's why they just cannot intersect. Now for another question. For any given problem, how many indifference curves are there? Technically, there's infinitely many indifference curves for every problem, one for each utility level, and there's even indifference curves between indifference curves. So that's why it's always, there's infinitely many. We only just represent a couple of them to sort of, you know, solve the problem or do what we need to, but technically, there's infinitely many. Well, I hope you now understand economics better, and if you really want to make sure you've mastered the concept, check out our active learning customized platform at bestecontutor.com. It's like having a one-on-one tutor right in front of you 24/7. You can click here to try it out for free. And we'll be adding more topics and videos on YouTube, so make sure you subscribe below for the latest updates.